how you can combine OpenEdge with AI, artificial intelligence, and to give you some examples, what is the purpose and the outcome. My name is Klaus Erichsen from company IAP, and I'm a long-term OpenEdge developer.
Yeah, and I'm Steffen Maas, founder and managing director of Ginko Analytics with 10 years of experience in consulting and now heading a small AI expert group. Happy to be here.
Okay, yeah, let's talk a few words about IAP. IAP was founded by me and some colleagues about 30 years ago in Hamburg. We are mainly a technical service provider and mainly for OpenEdge with our 40+ team members. And beside helping companies for developing the application, or we do the whole service, we have also our low-code system OF1, the Object Framework 1, which we developed over the last 15 or 16 years. It's a pure OOABL framework, and it has multi-UI capabilities. We can have a .NET UI and an HTML5 UI, and everything will be programmed by or with the ABL. Good, that should be enough. Yeah, AI. There's a great AI vision. It's 50 years old from Stanley Kubrick, the great director. It's a computer, HAL 9000, in the film 2001, A Space Odyssey. It's a kind of a panel. You can talk to the panel. The computer is very clever. He can talk to you, and he can control a whole spaceship. So it's that time, so long time ago. And what do you think how AI approaches in our houses? Yeah, everyone will know it. It's Alexa. And you can talk to Alexa and she will answer. She's very clever. And the thing what we see as a programmer is that you can program abilities in Alexa. It's called a skill, and you can add your skills, and that's something you should think about yourself when you hear our session. So when will your ERP system be able that you can ask at the end of the day, Alexa, what was my revenue of yesterday? Good, and now I hand over to Steffen.
Yeah, thanks, Klaus. Quick introduction from my side. I'm from Ginko Analytics. Ginko Analytics is a spin-off from Ginko Management. We are a company specialized in data and AI solutions. And in a nutshell, we implement customer-specific AI solutions. So everything which you can't buy on the market. And we are working mainly for large customers where we are strategic data and AI partner. We are now 40 people, are based in Hamburg, but also have offices in Munich, Berlin, and Frankfurt, and do quite everything which is related to data and AI. Next, please. Quick guidance for today. So what we would like to answer is the questions of why, what, and how. So why is it important? And in a nutshell, there's a revolution coming. I strongly believe that AI has a big impact on us and our business and how we do business. And I think it's really also a threat to the economic core, especially for small and medium-sized enterprises, because we see a lot of different players in the market. And I will touch that. Then the what. So what can we do, and what are the possibilities we can do with AI? I will introduce you with a method called Use Case Radar, and also highlight some very recent examples where we have implemented some things based on ERP data. And then I'm handing over back to Klaus to explain a bit on how can this be done? Yeah, so which technical possibilities are there which we can use. So next please. when we talk about AI, I really love Kai-Fu Lee, because he has he put it in a nutshell and said the AI revolution will be fast and branching, but in 50 years we will be glad it came. That means AI can do a lot of things for us, and it can make our lives very, very easy. And I think it's also something, it's not a hype which is coming and going. It's more a long-term change of everything which surrounds us. And I strongly believe companies in 10 years will not be the same as today. So next, please. What we see, especially here in Germany, is that a lot of people do not treat this seriously. One example here comes from a newspaper from August, where they really stated that there's a lot of funding available in the market because the government also sees the importance, but only a fraction of it has been used, at least here in Germany. And I think same thing in different countries as well. Next, please. I have 2 postcards for you. I was bringing from Texas, for example. So one postcard from a production area in Tesla. You can see there are nearly no people. It's optimized, and you can replace Texas in the meantime in a short term of time with Grünheide. So it's coming closer, and it's also affecting the way how companies operate their value chain at the end, and it's really increasing in tremendous, and the progress is tremendous what happened there. The next example is from logistics, where we have one example from China, where you can see that also the picking and packing and distribution of goods, transportation from A to B is happening in a really automated way, where you have semi-automatic robots operating in a mesh, and transportation is happening self-optimized and in a self-organized way. Konnichiwa. So what does that mean? Next, please. When we look at a broader scale, why is this really important for Germany, but also for Europe? It's coming here from Germany because we work together with AI from Hamburg. It's a local network of people who are pushing AI into companies, and we see strong trends. The first is China is really having a strong AI strategy, and it's pushing AI in every corner. It's investing a lot of money, so it's coming from the government. It's 150 billion to bring it to every area, business, administration, universities, and it's really very, very strong. The second trend is from the US. And here we know already all the big companies, and they are having immense investments into AI, and they have very large funds, and they just enlarge their business. So Amazon is not a shopping mall anymore. They are also doing transportation, and soon they will also do production and produce things. So they are extending their reach, and they are using their technology power to also optimize their businesses. So as a result, we see the trend that Germany and Europe is falling behind, because we don't have neither the one nor the other. So we don't have 150 billion, and we don't have that much investments here as in the other areas. So the only thing where we see how we can overcome this is by joining forces and collaborate and cooperate. That's why I'm happy to be here with Klaus, that we can leverage the knowledge we have in different companies to find solutions also for not so large players which are operating on a global scale. Next, please. So when I talk about AI, I can talk 2 hours about AI and what are the potentials. In a nutshell, it's really, really reliable in the meantime. It's very cheap and it's very fast. So a lot of companies have invested a lot of money, and they have gone all the way. So it's, for me personally, it's a key technology of the 21st century, and we can automate things. I call this hyper automation, where we in the past needed a person, in the future we need a computer. And second thing here is also to not look at the past, it's more looking also in the future. It's about predicting things. Then a trend is that really AI solutions are becoming more and more mature, so you can really use it for production. A lot of tools are open source. That's why I really love doing business here. We have all the tools which we need to solve the problems. We just need to assemble them in a way that it makes sense and that it's working as a solution. And at the end, yes, AI will change the way how we do our jobs. But at the end, there are new jobs and new job descriptions. So if you have done repetitive tasks in the past, you will do data tasks, visualization tasks, and machine learning in the future. So when you look at AI, next please, then what you can see is that it's not progressing in a normal way. So everybody knows Moore's law. The power of computers is doubling every 2 years. So it's quite linear. In AI, it's a bit different. And it's difficult to understand. So I try to put it here as a visualization. It's more the exponential growth. So there are a lot of research being done, and it's really, really going through the roof. And you can see that it really good in the number of papers. There's no recent, more recent numbers than 2017, but I think if you even do it now, it's going even higher. So sometimes we are seeing things which are possible today that haven't been possible yesterday or 2 weeks ago. So next, please. So if you are not into AI and you say, I don't know what's possible, I always cite this website. It's State of AI, and it's a report which is assembled by 2 very smart guys once a year. So if you don't know anything what is possible, look into this report. It's like 80, 90 slides, and they are highlighting everything which is possible now, and all the problems and also all the opportunities. And it's really well made, so have a look at it. In a nutshell, next please. So what do we do is what we take data and it's coming from different data sources, and it could be master data or transaction data from the ERP, but we also combine it with event data, IoT data, social media, geo data. And what we do is we use AI methods, which is our tool chain, and combine it to implement AI use cases. And as you can see on the right side, there are a lot of use cases which you can do, and it's always in 2 dimensions measured. One is the impact on the company, so will it change dramatically or it's just a small minor tweak? And the second thing, how difficult is it to implement? And in these 2 dimensions, you can measure all the different use cases. So next, please. To make it a bit more concrete, I brought with me the AI use case radar, and here it's one example from the production area, and it's just giving a brief idea of what is possible. It's neither complete nor representative for every company. It's just an industry evaluation to show what is possible. And as you can see on the outside, there are things which are not yet there. It's something where a few companies might have implemented something, but it's really a competitive advantage. On the other side, you have things which are in the middle, which is available as a standard product. And you can see there are different use cases along the value chain, and the more it is in the center, the easier it is to buy it off the shelf. And then you have the business impact in the size of the bubbles. The higher the impact, the larger the bubble. So it's very, very easy. And as you can see, there are a few large bubbles. One is, for example, production and program planning. The better it is, you can plan ahead, the more is the impact on the business. And the second thing is quality optimizations or even storage space optimizations. It's something where you can really have a high impact. And what we have done for today is I'm bringing 3 examples. So next, please, Klaus, where we can really deep dive a bit. One is the area of quality optimization, where we have one example from a tire manufacturer. Then we have digital twins, where we have implemented something in a European project, and we have material planning, where we have did a better forecast on the material. So let's start with the first one. Next, please. that is the quality optimization for a tire manufacturer. And I'm not going into detail of everything. So if there are questions, feel free to answer afterwards. I'm free to answer afterwards. But here the thing is, we have a situation where things are done manually with Excel or with very limited use of the available data. And what we have done here is we have implemented an Azure Data Hub. So Azure is from Microsoft, the cloud service, and we have imported here all the different data from different data sources, created real-time data pipelines and built models that evaluated how good the quality is. So, and at the end, you had a really good classification algorithm who could put a stamp on the tires that said, okay, this passed the quality or failed the quality. And with that, it was really a great step towards a smart factory, because with that, you could provide the insights to the people on the shop floor, and then they could improve the operations. And besides the direct quality improvements, you also have the good understanding and can go into the root causes and find out why is sometimes the good quality and sometimes the bad quality. So the next example, next please, Klaus, is one example where we have worked together in a consortium of 18 European SMEs, where we have built a platform, also not in the cloud. Here it's more based on open source, where we have this situation that a lot of small and medium-sized enterprises at the end don't have the capacity to build their own solutions. And they might not, they don't want or they cannot use the public cloud infrastructure. And here the idea is to really build something based on open source, which is available to all European SMEs. And it's a project which is running since 1.5 years, and I think it's running 1.5 years more, where we then have a platform available where you can have a shop and buy different modules. And we have, for example, integrated an anomaly detection module, which detects anomaly, for example, in cell, so battery cell production, and highlights things which are not yet right, and where you need to rework and need to do something to make the battery also with a very good quality. And here at the end, we have an integrated solution which is available and where people can then connect their data sources and use the available data models and also the visualizations to then improve their processes. So last example, next please, is coming from the railway industry, and it's going into the material planning. And also here we had really Excel and formulas which made the forecast. And here we did a similar thing. We also extracted all the different information. It was mainly from an ERP system. And we did a proper forecast with machine learning. And here we were talking about secondary material used or required for maintenance, and it was really a lot. So it was more than 300K of different materials. And at the end, there was a way to do a proper forecast and save at the end material in stock, but also in not available stock. So it's always a trade-off of buying too much or too less. And there has been a saving of more than $1 million. So it was definitely worth using machine learning here on ERP data. And just to give you an example of a few things we have implemented. Okay, last example. I think one example we have done very, very recently, last week, where we got OpenEdge ERP data, and we did some very quick analysis on the time tracking data sets. And as you can see, the colleagues have visualized this data. One is a word cloud, which is showing you how often different descriptions are used in the time tracking, and on the lower ones you can see time series analysis, where you see for the top 10 categories how much time has been tracked in this area. So that's very, very simple approach. So at the first, it was definitely worth looking at the data to see if it's consistent, if it's complete, and so that can be checked, and we can say, yes, with this data you can do something. And for example, now you could train an algorithm which detects which learns normal behavior, so how normal time tracking looks like, and then also detects anomalies. For example, there's something which is booked on weekends or holidays, and you don't need to have strict rules. So in the past, you had said if time is booked on the weekend, flag it as wrong. Now you have an algorithm which learns this on its own. Or the second example, which would be to really then also detect errors. So booking something to something which is not existing is not good. Okay, so lastly, one overview of what we do and how we do it. So our methodology is quite straightforward. If there is an idea of what can be done, we slice it into smaller pieces. So the first step was the recent example. That's the prioritization and preparation example, where we look really just at the data to understand also what the problem is, if the data is there, and then we have a first understanding. So that's an effort of 1 to 2 days. Then we look into the proof of concept, where we say, okay, now let's build an algorithm and try out if there's an outcome. So that's normally 1 to 2 weeks. And then if we see that this is working in theory, we build a so-called MVP, so minimum viable product, which is then used in a productive pilot and which can be used in, I don't know, one area. This is normally an effort of 1 to 2 months. And then if you are a global company and want to roll it out globally, it depends on how much countries you have, if the model needs to be adapted, and so on and so on. But it's definitely not a lot, and it's not half a year projects or 1 year projects. It's more or less. Good, so that's our methodology, and at this time I would like to hand over to Klaus to explain a bit more on the technical details. So how does it look like? What possibilities do you have with OpenEdge?
Yeah, okay. So what we've learned is that the AI system is a separate system, and I will talk a little bit about the technologies you can use in the OpenEdge world. Here on this slide, I have the REST adapter. It's ready or available in the classic app server and in the Pasui. The REST call is some kind of an URL. You see an example here in the top area. It's pointing here to localhost. It's an OF1 business entity of the type order, and you can give parameters like sort or filtering or what you want to get back. This REST adapter works in both directions. You can call a REST service, or you can be a REST service in OpenEdge, and it's completely universal. You can do more or less everything with it. If you have control over your ERP system, then you can export data like our data Steffen showed there, and then send the results back. The setup in the Pasui is a little bit tricky, but after the setup is done, it's running smooth. So second here is the idea of not having the AI system running locally, but to put it in the cloud. Then the AI company can say, okay, here's my default AI system. Just push in your data and get back the results. I will do the calculations for you. So the idea is that you have the AI as a service, not only locally. In this case, you can use any export import which is available from the AI system. And in this slide, idea is the tight integration, that the AI is really part of your application. Let's say you get a big order and you must see, I'm able to fulfill the order in time or not. Because if not, then I lose some money because I get some penalty. So you have all data in your AI container. In this case, it's a Docker container. And then you send a REST call to that system. System has all data and all the calculated stuff for that. And it say yes or no, or gives you back a percentage. So you can use this local or maybe remote in the cloud system if it's fast enough, like an integral part of your application. So that will be ideal solution for you, I think. Good. Yeah, that's it. That was a very short overview, less than 1 minute per slide. And now we are open for questions.
Yeah, we have some questions. One is, what cost and time frame can I expect for a first starter project?
Yeah, I can take the question. It depends on the scope of the project. If you want to implement a solution end-to-end, yeah, it's as I said, 3 months, and roughly we calculate with yeah, for example, 1,000 euro per day. So it's normal. It's a one person project. Normally we do two people on a project, so it could also be shorter. Yeah, it's 3 months, 50,000 euro, something like that, I would say, for a first pilot.
Okay, thank you. And another question is, what are the most promising use cases in the production area?
Yeah, in the production area, we did a similar session with Pro Alpha customers and users. In the production area, it's the quality. So how good do I produce something? And how can I avoid mistakes? So Internet of Things is one word where you say, okay, I check what the machine is doing, what the sensors of the machine are giving information. Is the product at the end good or not? And the second big area is organization. That means production planning, personnel planning, material planning.
Okay. Then we have, which data sources can be used as input for machine learning?
I think it's as I said, you can use different data sources. For example, if you take the production example, the normal thing would be to use the ERP data. But we also see the trend that more and more production manufacturers are using IoT data, so you can either retrofit your existing machinery or buy new machinery which is already pre-equipped, where you have sensor data which you can use right away. And the more data you have here, the better it is. And you normally need, I don't know, 3 months of for example, IoT data to generate a model, and you always need training data, so that's important. And the more data sources you have, the better, because at the end, machine learning works with features, and these features can be generated out of the data. But we also see, for example, manufacturers which are using their currently analog data, so for example, quality checks, yeah, quality documentation, which is very, very important, because I can see here what the outcome of a production step is. So if I capture that result in a digital form, I can use it as an input variable for my machine learning algorithm to say, please optimize this with different settings, yeah, different materials, different suppliers, different settings on the machine, and I always get the optimum for different input parameters.
Okay, thank you. The last question is, how difficult is it to implement a customer-specific AI solution?
Yeah, Klaus, what would you say?
It's hard to say. From the OpenEdge part, exporting data on one of the APIs is not the problem. On the AI side, I think you need someone who has an idea how it should work. Otherwise, it's a big effort.
On the AI side, I must say, depending on the use case, sometimes it's really done very quickly. If we have the data, we have some modules are pre-available as frameworks, which is also very easy to implement. So we always use REST services, which can easily be integrated in existing environments. I think building something is not easy. It's quite easy. Integrating it into the existing ERP system or providing a new front end, that's the more difficult thing. And also changing the processes, so doing the transformation. That's the more difficult thing.
All right, then thanks for the answer and have fun. Because I'm switching now to another screen.
Yeah.
All right.
Okay. Thank you.
Bye-bye.
Bye.